One very quick topic that I want to introduce to you because it's going to be super helpful when we go into some of the data structures is this notion of member classes. It's a class within a class. So the idea behind an inner class is to say sometimes a thing is made up of parts that are only useful in that thing, but that thing can't be the thing without it. So on the left hand here, we have a picture of a clock, and there's probably, in any watch and a clock, there's little gears that are made for that clock that might not be useful for anything else but the clock. And this is true of all sorts of machines. I mean, there's parts on a car that are only useful for cars. You wouldn't have them on a horse and buggy. Brakes, sure, you might have brakes on a horse and buggy, but you wouldn't have a muffler on a horse and buggy, for instance. Um, and so the relationship is often really important. Like I mean, you can have an engine without a muffler, but it runs better. It's safer. You're not allowed to drive in many states without them. Um, Another example we can talk about here is this idea of an order and a line item. If you were to go buy something from a an online store, particularly we're talking about software here, I put it in the shopping cart. Well, I need to know what the product is and how many of them you want to buy. That's what's called the line item. So without an order, what's the point of a line item? It doesn't have any purpose. But without a line item, how do I know what I'm ordering? I mean, I need there's synonymous relationship. So in order to create a line item, I need to know what order that line item's for. I can't just have my shopping cart accidentally fall into your shopping cart. On a virtual sense. I mean, if you're talking about a store, sure, you can steal items from my cart. But in this case, I need to know when I create a line item, who's buying it? Which order does it go into? Which shopping cart does it live in? And so this back and forth, really important nature is something we can reflect in our Java classes. So here's an example of that order line item here, where the order class is the outer class, and then we have this private class inside line item. It doesn't have to be private. It could be public. It could be um, protected. It could be any of the default modifiers. If it's public, it's something that other people can see, and then they can access it by saying order.line item, kind of like a package, but a little bit different as well. Um, if it's private, then I can just entirely hide it inside. Nobody has to mess with line items. I can just say add this product to the order, and it creates the line item internally. So in the order object, we can refer to that as order.this. So somebody goes off and creates an order object, and then they do that through the constructor, my order. So at some point else, we can say order dot line item. That would be a type that's in my system. Again, if it's visible. If I'm inside the order class, I don't have to say order.lineItem. It already knows about that. But externally, if I need to access this would be the syntax I use. And so then if I want to create a line item, I have to do that through the order. So I either have to be inside the order class or I have to tell it what order class I'm working with. Excuse me one second. Sorry, I suddenly had to sneeze during my recording here. So the order line item relationship is such that I can't, for instance, um, I can't. If I could grow an extra kidney in a lab, I still need to take that kidney and put it in a person in order to have it be viable. It won't survive on its own. So maybe the fluids will help it for a while, but eventually it needs to live inside of a person. So what person is going to be in? Well, genetics tells us that, hey, we need this kidney to match the genetics of the host, otherwise they might reject it. So that's not the happiest thought, but that's the kind of the same relationship between here. The line item has to be created within this. Now, you can avoid a lot of this extra syntax within your code because there's an implicit and automatic relationship that's created. And I don't have to explicitly give that information so long as I create the line items always within the order. So if you have code that you want to create, you have a larger data structure and you have a smaller class that's going to help organize that data structure, you don't have to deal with all of this semantic, order.line item sort of stuff, syntactic stuff, I should say, if you stay within the class, but at least you're aware of how this works and aware of what the relationship is. The other cool part about this is there's a special permission, there's a special relationship for the inner class. So in this case, the line item, when I am in the code for the line item, I create the new line item, it can implicitly just update the subtotal automatically. When you add me in, I just add in the subtotal, for instance, for the order overall. So there is the relationship back and forth where the order, the outer class structures the inner class, the line item, but the inner class, the line item, can also organize the outer class, the order. So there's a back and forth. Now, let me tell you, generally in Java programming, this inner class thing is rare. But in this class in particular, it's very, very useful in a few spots. There's several data structures that use the idea of an inner class, some of them private and some of them public. You won't see the inner class implementations for lists or sets or trees because you don't need to. But you definitely do for maps. Maps have a key value pair, and it will create an inner structure for that you can go off and get just from the basic Java ones. So you can use this occasionally as you need to help organize your code. Not that you can't use external classes, but this is a way of really ensuring the integrity of the data as you work through your data structures, and it might help you to organize your algorithms a little bit easier as well.